Okay, so we are still displaying and interpreting data, but today we're going to add to what we've been learning. We've been learning frequency charts and cumulative frequency charts. So we're going to add on to that. So the first one we're going to do is a line graph. So fill in the blank. The purpose of a line graph is to show change over time. So that's the purpose of a line graph, is to show change of something over time. All right, so here's an example. The number of annual visitors to the Grand Canyon is given in the table here. You're going to construct a line graph of the data and then use the graph to predict. I want you to circle the word predict. Line graphs are used for predictions. Predict the number of annual visitors to the Grand Canyon in the year 2010. Okay, so when you do a line graph, the time goes across the bottom. In this case, it's the year. And eventually, we're going to do 2010. So I want you to add 2010 over to here. You can, by the way, draw the labels sideways or regular ways, whatever fits. So time is across the bottom. And then what you're measuring. In this case, it's visitors in millions. All right, so we're going to plot some dots here. So in 1960, there was 1 million. So go straight up the 1960 and put a dot at the 1. 1970 was 2.2, so it's going to be just barely above the 2 line. 1980 is 2.5, so put the dot in between the 2 and the 3. 1990 is 3.5, so put the dot in between the 3 and the 4. And then 2000 is a perfect 5, so go up to the 5 and make a dot. Now, unlike a best fit line, which we will actually do second semester, when you do this kind of a graph, you draw the line from dot to dot. So this is where you're going to use your straight edge. You're going to connect dot to dot. So it's not going to make one straight line. You're going to have lots of segmented pieces. Okay. So on this, the biggest increase is the steepest line. The biggest increase is the steepest line. So if you look at this, there's 2 pieces that are the steep ones, 1960 to 1970, 1990 to 2000. And this one, 1990 to 2000, is a bit steeper than this one. So if you had to know the years with the biggest increase in visitors, it would be 1990 to 2000, because that's the steepest piece. All right, so now we're going to make a prediction. And again, you can use your straight edge to help you with this. If you were to put your ruler right through the middle of the data. So usually you want the same number of dots on top as on bottom. And if you were to extend your line out using your straight edge so that it crosses where it says 2010, that is our prediction. And yours might be a tiny bit different than mine. That's what happens with hand graphs, so that's okay. So at 2010, mine looks like it crosses about there, which is at the 6. So I'm predicting the number of visitors in 2010. I would say about 6 million in 2010. So that's how you do a prediction. You kind of figure out where the data is going and see where your line would probably cross in 2010. Okay, that's our first type of graph. This is a line graph. It shows us change over time of one thing. Okay, second type, histogram. A histogram, okay, we're going to fill in the blank here. A histogram, the purpose is to display data from a frequency chart. So frequency charts and histograms are related. So here's a frequency chart here. It says the following frequency chart shows the number of club members in 20 high school clubs. Draw a histogram of the frequencies. So this is the size of the groups, and then this is the number of clubs that have that many members. That part got chopped off. Okay, a histogram. A histogram's not a bar graph. A bar graph has usually pairs of bars with spaces in between. In a histogram, the bars touch. That's why it's so easy to spot. So when you make a histogram, the categories go at the bottom. So write categories down here. In the case of this data, the categories are the different sizes of group. That goes across the bottom. And so you can see I've taken the groups and just used 2 spaces each, 0 to 9, 10 to 19, 20 to 29, 30 to 39. Okay, on the side is always the frequency, how many times it happens. So for 0 to 9, the frequency is 3. So go from 0 to 9, go straight up, put a line at 3, and draw in your bar. Now, rather than just scribble a bunch of stuff, we usually just stripe the bars going different directions so you can see them. Spending lots of time scribbling things in is a waste of time, so we don't usually do that. All right, 10 to 19 is 6. So we're gonna go up to 6. Remember, your bars need to touch. And then I'm just gonna stripe it the other way so you can see the difference. All right, 20 to 29 is 6. Oh, shoot. 10 to 19 is 8, excuse me. Got to make that bar a little bit taller. There we go. 20 to 29 is 6. And then 30 to 39 is 3. Sometimes on histograms, they'll actually put your count at the top of the bar. So like this would be 3, 8, 6, and 3. That way you can tell how far up they go. But the main purpose of a bar graph is to give you a visual of the frequency chart. So again, we have kind of a bell graph, sort of, on this one. You can tell the maximum number, the category that had the most clubs that had was 10 to 19 members. So that was the 8. That's the one that was the most popular club size. All right, flip it over. Okay, I'm pretty sure you've seen histograms before and line graphs, but a lot of you have probably not seen stem and leaf plots. So stem and leaf plots, the purpose is to display data that emphasizes the differences of the data. So it focuses on showing how things are varied. So here's how you do it. Write the data from least to greatest. Determine the stems, which can be 1 or 2 digits. Determine the leaves. This is the important part. Underline this, which can only be 1 digit. The leaves have to be 1 digit. Everything else is flexible. 1, 2, 3, 4 digits. The leaves have to be 1 digit. So here's our example. Seedling heights. They planted some seeds and then they measured their heights. Create a stem and leaf plot and then state which size of seedlings was the most common. Okay, so if you look at your data set, 3 pieces of data start with a 3. So your first stem is a 3. And then we have data that starts with 4s, data that starts with 5s, and data that starts with 6s. You always go least to greatest, top to bottom. So the stem is the first number, the leaf is the second number. So back to the 3, our data is 3.2, so you're going to put a 2 to the right of the line. That's the leaf. Then we have a 3.5, put a 5. 3.7, put a 7. Now, the next set are the 4s. So the numbers for the 4s are different, but they still sort of line up. So 4.0, the O lines up with the 2. 4.6, the 6 is under the 5. 4.9, it's under the 7. Okay, now the 50s, I have a 5.3. So put a 3. And I have another 5.3. And now the 60s, 6.1. And then we're going to do a key. So 6 bar 1 equals 6.1. You have to put that so people know how to read the numbers because they're not always decimals. All right, that's a stem and leaf plot. Now let's answer the question. Which size of seedlings was the most common? So looking at this, the only 2 leaves that happen more than once are right here. So the answer would be 5.3 inches was the most common size. And the length of the leaf part tells you how many data are in that set. So you can really easily see that most of the data is in the 3 points and the 4 points. All right, so let's do one more of these. Okay, this is just some random data set. I didn't give it a name. So the stems are the first number. I have some 1s. I have some 2s. I have some 3s, some 4s, and a 5. Now, this data is already in order from least to greatest, so you don't have to put it in order. So it's pretty much already in order. So let's do the 1s. I have a 14 and a 19, so a 4 and a 9. Now the 20s, 22, 24, another 24, and a 28, so 2, 4, 4, 8. Now the 30s, I have a 30, so 0, and a 36, 6. Now the 40s, 44 gets a 4, 49 gets a 9, and I only have one that is in the 50s, that would be 57. So our key is 5 bar 7, in this case is 57, whereas the other one was a decimal, this one is not. Okay, so give the median or the middle number. So to find the middle number, you need to figure out how many pieces of data there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you're going to have 5 and 5, and the middle one is in between. So let's count 5. 1, 2, 3, 4, 5. That's the one that's in the middle, which is 28. Number 3, give the most frequent number in the set. The only leaf that appears twice is these 4s. So 24 appears twice, so that is the most frequent number. Now, frequent number is one number. If they ask you for the frequent range of numbers, you're looking for the whole row. So if we look at this chart, the longest row is on the 20s. So that whole row is in the 20s. So your range of numbers would be 20, in this case, to 28. That would be the range of numbers versus the most frequent number, singular. All right. Are there any questions?